Hello students, this lecture is about negative feedback. Negative feedback is the driving force. It's the mechanism behind homeostasis. It's negative feedback. Negative feedback is causing this oscillation in the physiological parameters. Remember in the lecture I gave you on homeostasis, I noted that when we controlled physiological parameters such as body temperature or blood pressure or blood glucose, it wasn't just a steady flat line. Rather, there was an oscillation around a particular set point. So in this case, our normal body temperature is 98.6 degrees Fahrenheit, but we oscillate around 98.6 degrees Fahrenheit. Our body gets a little warm, and then our body initiates the mechanisms to cool it off. And then our body gets just a little cool, and our body creates mechanisms that warms it back up. So in actuality, our body temperature oscillates from around about 97 to 99 degrees Fahrenheit. And the force, the mechanism that creates that oscillation and that ultimately is involved in maintaining that stable environment that we see in homeostasis is negative feedback. And so we're going to take a look at how negative feedback works. And as an example, we're going to use body temperature. So here we go. First of all, remember the three components of homeostasis, and these are the components of negative feedback. We have receptors, we have the control center, and we have the effectors. So we start here. It's hot out. It's the middle of summer, and I'm out in the sun mowing my lawn, and I'm getting really hot. And so my body temperature starts to rise. As my body temperature rises, there are temperature-sensitive receptors, temperature sensors in the skin and the brain that are measuring that rise in body temperature. And those receptors, they then send that information along the efferent pathway to the control center. The control center is located in the brain. And the control center in the brain receives that information, and the control center realizes, wow, my body temperature is rising. I'm getting hot. And so the control center then analyzes that, makes a decision. It then sends information out the efferent pathway to the effectors. And in this case, the effectors are the sweat glands. And I start to sweat. And by sweating, that will help to lower my body temperature and bring my body temperature back into balance. Now let's go the other way. Let's take a different example. Now in this case, it's the middle of winter. And it's very cold out, it's freezing, it's snowing, and my body temperature starts to drop. My body temperature is getting too low. Once again, there are temperature-sensitive receptors, temperature sensors in the skin and the brain that are picking up on that drop in temperature, and they send that information along the efferent pathway to the control center. And the control center receives that information. It receives the information that my body temperature is dropping. It analyzes that, and it makes a decision, and it then sends information out the efferent pathway to my skeletal muscles, and it starts my skeletal muscles to shiver. It starts getting my skeletal muscles to shiver, and in those skeletal muscles shivering, that generates body heat, and that will begin to raise my temperature back up. So in this case, the effector are the skeletal muscles. And so this is negative feedback. Again, negative feedback is the mechanism behind homeostasis. Negative feedback, one critical thing about negative feedback is, in negative feedback, the response is always opposite the stimulus. So in this case, in negative feedback, if my body temperature rises, this negative feedback mechanism comes into play and it lowers my body temperature. And the flip side of the situation, if my body temperature is getting too low, negative feedback will kick in and it will raise my body temperature. And so once again, negative feedback is the driving force behind homeostasis. Thank you.